Hi everyone, in this video I'm going to give a quick rundown of integration by parts. Let's get started. So we're just going to start off with an introduction, and I want to introduce the formula that's used for integration by parts. So we have u dv is equal to uv minus v du. So what's the idea behind using integration by parts? Basically, we are given an integral to solve that is going to be of this form, so the left-hand side. And the goal is to put it into an easier solvable form on the right-hand side. So we're given something that looks like the left-hand side, and we look at it and we say, I don't know how to solve this. So I'm going to put it into, if I do it properly, into the right-hand side, which it will be easier for me to solve. So let's use an example to see how we can plug stuff into this formula. So as an example, let's say someone asked me to solve ln x squared dx. Now, how do I know what to pick for my u and my dv? So I know I have to pick a u, and I know that if I do pick u, I'm going to need the derivative of u, which will be du. So whatever I pick for my u, I should know the derivative of it. Whatever I pick for my dv, I should know the antiderivative of it, because v is used there twice. So I'm going to pick my dv to be x squared dx, and I'm going to pick my u to be ln x squared. Now, if u is equal to ln x, then du dx, which is just a derivative, right, is 1 over x, and so du is 1 over x dx. So I have two things that I need to use in my right-hand side formula. So I need a u and I need a du as well. Now, I have my dv, which I chose to be x squared dx, and I want to find v. So I'm going to take the integral of that to get my v, and this is an integral that I know how to solve. It'll be x cubed divided by 3, and so this is now my v. So I have the v that I also need to sub into my formula. And so by doing this, I had to solve ln x squared dx. And now I'm going to start plugging in things to my formula. So I have a u first. So my u is equal to ln x. Second is equal to ln x. And then I have a v, which was equal to x cubed over 3. And then I'm subtracting. So this part here doesn't even need to be integrated. So that is just already done for us. Then I have to take the integral of whatever v is. So again, v right here, x cubed over 3, and then du. And du I have right here. So that's the last thing I need to solve. I need to plug in, so that would be 1 over x dx. And so I can cancel that out. And so in reality now, the answer to my question, my integral, is going to be x squared over 3 dx. And this integral is a lot easier to solve than the original integral that I was given. And in when I find the integral and when I find the integral of this circular part, then this entire thing will be the answer to my question. And so that's kind of the idea behind integration by parts. So we're going to start off with an easy example. Let's say we're asked to solve x times e to the power of x dx. And I'm just going to put the formula up here so we have it to remember. So the formula goes u dv is equal to uv minus v du. Now, if I pick dv to be ex dx, I know that I can find the antiderivative of e to the power of the x because it will just be e to the power of x. So let me just pick x to be my u then. So if u is equal to x, then du is just equal to 1 dx. And if dv is equal to e to the power of x dx, then v is equal to e to the power of x. So let's see if I plug that in, if it really makes a difference into solving it. So I'm going to plug it in. I have u times v, so x times e to the power of x minus v e to the power of x times du, which is just dx. That looks beautiful to me. The x e to the power of x is solved for us already, and I'm subtracting the integral of e to the power of x, which is just e to the power of x. And so I already have my final answer. Okay, so we're going to move on to a bit of a more difficult example. So let's say we had x, the square root of x plus 1 dx, and I'm just going to write out the formula quickly right here. U dv is equal to uv minus v du. Now, you might be thinking that if I set the square root of x plus 1 dx as my dv, then this is a way harder antiderivative to find. So it's way harder to find v than if I had just set my x to dv. But notice that if I set my square root of x plus 1 to u, then du is just going to equal a half x plus 1 negative a half. And then, so since I set that to my u, my x dx is going to be my dv. And so my v is going to be x squared over 2. So this du, I'm going to have to plug in here, and this v, I'm going to have to plug in here. And so an integral on the right-hand side is actually going to be harder than the integral on the left-hand side that I'm trying to solve. So I would make my life harder if I chose that to be my u. So this tells me that choosing the square root of x plus 1 as my u is not the best option. So I'm going to go ahead and try the square root of x plus 1 dx to be my dv and x to be my u. So if u is equal to x, then du is just equal to 1, so it's just dx. And if dv is equal to the square root of x plus 1 dx, then I can integrate that by using u substitution, and I would get v is equal to 2 over 3 x plus 1, 3 over 2. So let's start plugging this stuff in. So I have uv, so x times my v, which is 2 over 3 x plus 1, 3 over 2, minus my v again, 2 over 3 x plus 1 to the power of 3 over 2, my du, which is just dx. Now you might be thinking, well, this might be a hard integral to solve too, but it's not, because it doesn't have this extra x here. So this integral can actually be solved by u substitution. So I can try to just make it a little bit cleaner for myself. So I'm just going to write x here, 2 over 3 x plus 1, 3 over 2. And let me take that 2 over 3 out. And I'll get x plus 1, 3 over 2 dx. And now I can solve using u substitution. So this can just be 2x over 3, x plus 1, 3 over 2, minus 2 over 3, And when I solve this using u substitution, I will get x plus 1 to the power of 5 over 2 plus some constant. And I can just simplify my answer. 2x over 3, x plus 1, 3 over 2, minus 4 over 15, x plus 1, 5 over 2 plus my constant. And so that now is my final answer. So it was a bit of a thought process to see what to pick for my u, what to pick for my dv. But again, I looked at my goal. I just wanted to make my right-hand side easier to solve, and that's what I did, which got me to my final answer.